And this is a dot release, which means they cleaned up some things on a bigger release. I like to say they're all golden when they get to the dot because everything gets tidied up. That is downloadable. If you're on maintenance, you can go use your GTAC account and download it direct from Siemens. And let us know because you have to register your IP. They require that due to various restrictions. They have to know where you're at. And that also includes an update to NX Nastran version 8.1. We're going to talk about visibility, little things that they added in the .1 that's very useful. It came out of a recommendation from our client that they should be doing this, and they incorporated it. We're also going to do some tricks on hexing and talk about some of my APIs that we've been using here at Predictive Engineering. So this is seminar outline, and this is being recorded, and this will be posted on the website also. So if people can't make it, you can follow along. And let's keep going. This is quick. When I get a new release, I tend to quickly read the documentation, what's new. This is inside Femap. And even though I read it, I skipped this whole thing about visibility. And I was talking to one of the developers, and I said, did you guys ever get around implementing this client request? And they said, yeah, we did. It's in the what's new. So I had to eat a little humble pie, dig through and look at it. And we're going to cover this on the visibility side. And let's talk about Hex Machine. This shows one component. It's an air inlet vane nozzle vane guide, and it's all hex meshed. And there's another part. There's a turbine rotor that required to be hex meshed also. And I'm going to show the setup for that, the first part, because it's not exactly intuitive, and it's something that I had to get some assistance with figuring out. So here's the model. And one of the first things that I do is I look for symmetry, and in this case it's cyclic symmetric. And I had it sliced down into one blade segment. And I want to blank this part here, and I'm going to go to the selector entity, turn it to solid, right click, visibility. And I want to hide selected, like that. We're going to come back to it. I just wanted to give a quick overview to it. Adrian's going to show it more in detail, the visibility option. So in this condition, I'm going to turn off the selector because it's still thinking we want to select something. You just tap it and it goes off. If you go into Mesh Controls, Size on Solid, and hex it, it's going to balk at you. It's going to turn red. And let me turn on messages here. Solid 2 cannot be hex mesh. Well, yeah. I'm going to go ahead and Control Z and undo. Go back to my nice color. And let's look at how we would hex this. And people that have been working for a while with hexing would say, well, it would most likely hex if we get rid of this blade on top and hex it this part and then conquer this separately. So slicing something like this, well, yeah, it's not flat, it's not curved, it can be tricky. Here is what was shown to me. I'm going to copy that surface right on top there, and I'm just going to copy it out. And I'm hitting the tab key right here, and then backspace. I'm just going to move it out 5 units right there, and then I have this surface copied, and it has that for the outline. Then I'm going to go into meshing, feature removal, loops. Pick the selector, pick a curve, voila, it's done. Now I'm going to move that back. Modify, move by surface. I'll go ahead and select it, and tab and back, and just go -5. So it's back on there. I'm going to use that surface to cut these two apart. Solid, remove. And this is another command that I went, oh, interesting. That's how you use it. After all these years. And you can see it, that copied body, number 4 right there. This is our base. And there's our 4 right there. And it went ahead, and you may think, well, did it really do anything? You can always go on the tree and see what's there. There's the regular part. But we got 2 parts there. Now go back, click on this. Oh, I got to click on solid. See it highlighted there? Right click, visibility. Now, when you only have a few parts like this, you may say, well, what's the big deal? You just go for the tree. But think if you had a couple hundred parts in there and you're trying to figure out what part you want to blank. It gets a lot trickier. So from here, I'll go to Mesh, Mesh Control, Size on Solid, and Hex Mesh. Oh, I forget. When you're in this trips me up. When you're in the selector, even though we're out, it still has an item loaded in the selector list. And when the commands, it's a workflow thing. It says, well, you really just want to work with that item. So I'm going to clear the selector. So now it says, now once you have to tell it what you wanted to select, because otherwise it's loaded into the selector. And it comes up, and it shows it wants to mesh it, and you say, where are the curves? Well, it's something I blanked, like that. And it thinks it can mesh it. Because it's mapped this surface onto this surface, and it's pretty confident that it can extrude a mesh through that side. And then you would go into Geometry, Hex Mesh Solid, and you pick it. And I'm just going to do a trial here. It'll come up, and you go, well, it ain't going to work. And it says Solid 5 cannot be hex meshed. And what it does is paves over the surface with just plot-only elements. And you can confirm that they're plot-only by type, plot planar. And this is where it gets tricky. You go, okay, it ain't going to work. What do I do? What happens is that Femap needs to have these surfaces mapped. They need to be nice and smooth, so it can extrude from this surface over to this surface. And the way that you help Femap is Mesh, Mesh Control, Approach on Surface, and I'm just going to select all surfaces, and I want to exclude the two surfaces that map the mesh through the part. So we're going to take just these surfaces right there, and we're going to have Femap automatically map four corner to them, like that. Then Geometry, Hex Mesh Solid, there we go. 4,000, and you see the notes, 4,312 elements for this. And it's a beautiful hex mesh. And where this is all going, what I want to do is I'm going to show the geometry. Is that you can say, well, wait, you didn't do the blade. It doesn't count. Well, let me show you where it goes. And let's go to the full model. And this is for a LS-DYNA burst simulation where in aerospace this is a turbine, this is 8 inches in diameter, and it's designed to burst at 55,000 RPM, and you have to contain the fragments of the titanium rotor disc. And so you have to have a very economical model to do the simulation. So here's the full model. There's the geometry sitting in the middle. Let's turn off the elements there. Zoom in. And so this was the trick, is that you go ahead and you use these curves and you imprint on that top surface. And I'm going to go ahead and blank that. Again, visibility, hide selected. And you can see that surface. Maybe it's a little faint, so what I'm going to do is modify color surface. I'm going to make that bright yellow. Well, it's transparent, but you guys can see it. And what you do is you split the surface on top that follows the turbine blade, like that. And then you go ahead and set it up for meshing from top to bottom. And once you do that, I'm going to use Group, Generate on Solid. Pick that solid. I'll make a group go into here, right click, show active, and I also have to tell visibility that I want to see elements. And well, you can see I've worked on this model. I'm going off script, and I've worked on this model already. And so that's why they're not all connected. So let's just go back to the full model like this. Turn off the solid. And you can see how I mapped it up onto the hex, onto the blade. Yes, this did take a bit of work. Was it that intuitive? No. What were my alternatives? I did look around on the web for a hex meshing service, and I picked out one of the best, and I asked them, well, what would it cost to hex mesh this up? And they said, well, I mean, it'd be $1,000, and if you wanted to make changes every time you come back, it would be, I think they quoted, it was like $450 to make a change. And you can understand in modeling, you're always making changes. This is a relatively coarse mesh, and I went and also upped the mesh, so I had 4 elements across the blade and 4 elements through this view section. So it did take some work, but it took far less work than $1,000, and now I actually own the mesh. So if you guys get into something very tricky, very hexy, you think it might, it's a really difficult, give us a call, and we can work through some of the procedures of what's going on. So at this point, I'm going to pass it over to Adrian, and he's going to talk more about visibility. So I'm going to change the presenter, and there you go. Adrian, visibility.
There we go. You hear me? See my screen?
I can see your screen.
Okay, so I've got a little pressure vessel that I've been working on here. This is just part of the video. And this is a great model to show us the options because it's got so many properties. And right now, I've got
Hey, Adrian, that's what I thought. I can't hear you. Do you have the audio set to mic and speakers, or do you have it set to telephone? Because I can hear you in the office, but I'm seeing the audio still showing up on my side. Interesting. How do we set this? Because you're the presenter. No. It has me as audio. Yeah. Are you going to call back? Okay.
Figure it out and join manually from the website. You meant to, though. Yeah.
You know what? Hello? Who else is on this? I hear somebody else talking. Can hear him now. Okay. Okay, I'm back. Okay, good. I'm going to change. Adrian, did you log back in? There you are. Let's try this again. Adrian, it's your show.
Okay, I'm calling in right now.
Hey, it worked. I can hear you.
You can hear me on the line?
Yep.
Okay. And if I could get a confirmation from somebody in the audience, that would be good too. Let's see.
I'm looking.
Here.
Okay, good.
All right, thanks, Cody. Okay, so what we've got here is a pressure vessel, or a segment of a pressure vessel that I've been working on. And I like to use it for visibility options just because it's got plenty of properties, materials, different element types, different solids, plenty of stuff to turn on and off. And right now, I've reset everything using this button here. And this, for example, let's use visibility. And say I was to turn certain portions of my model off. I'll turn off loads, geometry, and nodes. And say I wanted to reset, turn everything back on, reset all visibility options. So that's a nice button to use if you get lost with something's missing and you're having trouble getting it back. So there's two main ways to tackle visibility. One is the visibility box, which we have listed here, view visibility, this button, or also Control Q is the shortcut. And there's plenty of different tabs here, and you can go through and turn on different entity types one by one, or by groups, like all of geometry, all of mesh, etc. There's also more tabs that will control your layers, your geometry, individual element types, or materials, properties, etc. And this is pretty similar to what you can get to through the tree. So you can either use this visibility box, turning things on and off here, or you can do the same from the tree. Here's my solids, here's my materials. And this is really self-explanatory. Just take some time to work your way through the tree and get used to where everything is stored. Now with George's model, he only had a few solids, so it was pretty easy from the tree to be able to blank certain solids, because with only a few, it was pretty straightforward. Let's say I want to go back to the visibility dialog. I just want to look at my solids right now. I'll turn everything off and look at my geometry. Say I just want this center solid here, but I don't know which, some of these are untitled. Can you hear me? Okay. All right, so I just want to see this solid here. Rather than searching through the tree for it, what I'm going to do is use that little selector trick that George had set up earlier. And we'll go ahead, grab solids, and you can see it's highlighted that solid. I'll right-click, and I can get to visibility here. Now I can show selected only, and there we go. I've got a few curves here that aren't associated with any solid, so they're still a part of the view. I can also use this to show all and reset everything. Another trick, it's the same trick but a different way to get to it, is you have three hands, and the shift key, and then right-click. It takes you directly to those visibility options using your selector. So same thing, just one less click. Now this isn't just for solids, this works for any sort of entities you'd like. So I'll go ahead and I'll switch gears. We'll play with the mesh. Now this time, rather than using solids, I'm going to use properties. And same trick, right click, visibility, show selected only. Now I've just got that one property that I selected. You'll also see some other elements in here. Those are rigid links, so they have no property. And if you've played around with any of the visibility options, sometimes you'll notice that you can show elements with no property. So since beams don't have since rigid links don't have a specific property, they're not turned on and off with the property selection. Okay, again, I can reset by showing all, and I could spend some time doing materials, doing element types, really whatever you want to do. These visibility options are now available from the selector. It makes things quite a bit easier. Now, I showed you the Reset All button here, turning everything back on. And it's kind of been a common request, is there a Turn Everything Off button, a blank all? And here in Patran, that's a common command that people can use, is blank everything, and then work your way back up, showing only the things that you want. Now, if you were to do this from the tree, it would take quite a while. There's quite a bit of different categories here that you would have to go through. Likewise, with the visibility, you would have to turn all off, working through each of these tabs. What we've got is an API program to do this for us. Now, I'll go ahead and bring this up. Tools, Programming, API Programming. Now first, I'm going to run the program just so you can guys see how it works. And then next I'll show you how to embed it into the Femap interface. So this API programming window comes up, and we're just going to open this, and here's the program file. You guys will be able to get a copy of this, and it's really simple. You open it, and you press play. There we go. We've blanked everything out of our model. Looks like we've still got points there, but as you look through the tree, all of my element types, all of my properties, my materials, everything is blanked. And so from here, I can work my way back up, just adding the components that I want. I just want plate elements, just quads, start picking properties, and you can really build up the model any way you want.
You need to click on materials too, Adrian.
Oh, there we go.
Yeah.
So you can see, once you blank everything, you really have to be specific with what you want to turn back on. So this API, in combination with this reset, gives you really ultimate control in turning everything on and off. But using this API programming window isn't the most convenient. It'd be a lot nicer to have a little button like we've got here. How we're going to do that is through Customize. So open the blank space up here, you right-click, you've got Customize, and we're going to set up a user command. Now what we want here is called blank all, and we just have to find that program. It pops to the last folder I had open. We'll open that, and we will add that to our list. Now I believe you still have to close your customization. It'll save that as a user command. We'll go back to Customize, and now under Commands, I've got my user commands. I can just click and drag, drop this up here. Now I've got this API program embedded in this button right here. You can see I click that, it runs the program. This same technique works with any APIs you want. If you guys find something in the custom tools that you like and you don't want to have to hunt for it every time, you can find those APIs in the API directory, and you can make a button for them right up here. I've done that with the free edge program. It'll flip the view so you only see element free edges, and it will flip back. I've also done that with the grow program, which I'll just show really quick. If you have a group, I'll show my active group, and you want to make sure the elements in this group are connected to others, I'm going to use my grow button, and it will grab nodes on elements and then elements on nodes. So you can effectively keep clicking this button and grow your model out from those original group of elements you had to make sure that it's continuous with the rest of the mesh. So again, if you guys find an API you like, you can set it up through Customize, User Commands. Okay, does that pretty much cover the blanking and visibility, George?
Yes, it does. Go ahead and cover the spreadsheet, and then I'll finish up with the PSD.
Okay, so our next model here, a little bit more programming, is our load spreadsheet that our engineer Nate had just set up. And this is a great spreadsheet. I've got it open here. And it's really set to use these 10 columns: load set ID, title, coordinate system, node, and then 6 components of your load. Now you can bring in any sort of loads, titles, numbers you want. You just want to dump it in these same columns, and you can hit apply. When you hit apply, it gives you some different options. First is the load location. Now we've got a column here for nodes, and so if you were to apply loads to 100 different nodes, you wouldn't want to select each one. If you could have it set up in your spreadsheet, this will say from Excel, it'll use what you've already punched in. If you didn't have that set and you only wanted to select one node for all those different load sets to be applied to, you have that option as well. Or if you want to manually select the node for each different load set, you can do that as well. Now this option doesn't quite as make sense for a big long list of load sets like this, but for shorter ones it would. I'm going to use select one node. Next option here is the load set ID. Now, if you have special numbering system for your load sets, and you have those entered into your spreadsheet, this API will allow you to use this load set for the load set ID within Femap. If you want this to be a part of the title rather than the load set ID, you can just start your load set counting at 1 or the next available load set, and you can combine this number and this title to be the title for your load set. I'm going to do the first option here. We'll hit apply. And we've got our nice little bit of landing gear here, and we need to select our node to apply load. Grab this here. Hit OK. Now you'll notice the spreadsheet is flashing. It's telling me that the program is complete. So you click OK, and we'll go back over to our model. And you can see that it's populated my model tree with all, I don't know, what is this, 50 or so load sets. You can imagine this can take quite a bit of time. Even if you're applying them to the same node for each load set, to do this by hand would be pretty intensive. So let's go back. This is a great spreadsheet. You can change any of the loads you want here. So you're going to shift things around a little bit. You need to change the title of something. We'll call this test. And we're going to reapply using the same commands. Select our node. And program complete. I'm going to check back on the landing gear. And you can see with the new changes I've made to my load spreadsheet, it's updated the model. Here's that updated title. If we were to look at the magnitudes of the loads, those would be updated with my spreadsheet as well. So this is a great, versatile little spreadsheet. Drop in your loads, and you're ready to go.
Nice. Pass it back to me.
All right.
And we'll go off to the PSD world. Also, one of the important things about that, it's data entry error. Always when you have to enter a bunch of stuff, going back and checking it and rechecking it, doing a spreadsheet, you just automate that process and you remove that variable. And we use it quite a bit when we have to do multiple loads and operations. And yes, it's a bit of a bear, the setup initially, but the downstream of just not having to deal with error checking is wonderful. Back to web meetings, API, PSD. I'm going to bring up this example model. And it is loading. It has to come on off our server. It's thinking. There we go. It's a fan controller board. It has components hanging off to it, and it's used for military applications. So they hit it with a PSD. And traditionally on PSD, it's the use analysis program to run the normal modes analysis, get the mass participation factors, and the mode shapes, and then you use a post-processing routine to extract do the PSD analysis. And it's a bit cumbersome. I prefer to keep it all in NX Nastran and Femap. And when you kick things out after you do a PSD analysis, you're going to get these things, RMS values. We're going to post data. And NX Nastran, being lean and mean, if you can get one thing done, if it does one thing and you can use a program to get the second thing, it will stop. It says our job is to get you one thing and to get it right, not to try to do 100 things and get 99 right. And so historically, NX Nastran, it will only give you the PSD RMS component stresses. RMS component stresses, and for plate elements, it's X, it's Y, it's XY. That's it. And the theory behind PSD would say, well, you really can't combine them because they occur at different phases, at different times in history. Well, theoretically, that's fine. Engineering-wise, do we really care that much? Not really, because the PSD process is very statistical. When you kick out a number from your PSD, your RMS stress, it's a normalized, it's a Gaussian normalized stress value. And in the industry, they always say, no, 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 we don't want the normalized value because that's only 66% of the time. We want the 3 sigma value. We want the stress value that it will be impossible for this stress value to be higher, 99.37% of the time. That's called the 3 sigma value. And so you take your RMS value, you multiply it by 3. So you get an idea of the uncertainty of the analysis work. It's a bit of a pun. So to keep things, just to make it simple, we wrote up this API that just goes in and does a von Mises combination of the RMS values. And we'll go into programming, API programming, load it up. Oh, it's looking. PSD. Oh, I was right there. Jeez, come back. Okay, web meetings. And this will, of course, will be on the web too. PSD von Mises, we're getting there. And there it is. And von Mises plates, and I'll do it for solids too. We'll do it for plates and hexes. And it goes through and grabs the values and calculates and dumps them out. And I've actually put this into my menu. You can see I have a bunch of stuff I added in. So you can run it both ways. And it asks for what stress set you want. I'm going to use the RMS values like that. And it goes through and calculates. And what does it give you? It dumps out the plate top and bottom von Mises stress. And it also gives you your magnitude, your total translation. Again, the same sort of punt. And it's very conservative. These values, if you do it truly numerically correct, it will be slightly less, 10% less. This will generate values 10% higher, which is a good thing. If you're used to doing analysis, you want to have confidence that your values are conservative, or on the high side. So that's what this little program does. And it shows that, of course, we're going to have the high stress here in the corner where it's bolted together. And this value you would multiply by 3, so you're roughly 700. So your reportable value is going to be 2100 psi. For the printed circuit board, the allowable is 10,000 psi. You're good to go. That's the sort of margins you want to see, a factor of 4x safety. That's it for our seminar this morning. It's going to be posted. Adrian, do you have anything to add?
No, I got a few follow-up questions on some of the API stuff, and I don't know if you guys want to go one more example of setting up a button. We can do that, or I can follow up afterwards.
I think, trying to think what else. I really like your visibility introduction. I was wondering where you were going with it, with the background, but I like the way you did the introduction to prior, this is the way we do it classically, and then, of course, you use a selector, and then you use the Patran, it's a little backdoor, little plot erase all. Hexing, I'm sure people will have questions in the future. That's about it. I like keeping them short and sweet. I would say, guys, if you have topics that you would like to see done, send us an email, and we'll work it in. We're looking for ideas. At the moment, we're doing a fatigue program that we're developing, myself and another analysis company out of Seattle, Endeavor Analysis. And they're the ones also supplied the landing gear model for us. They're I want to say the world's experts in landing gear analysis, and seriously, they're quite impressive. And we're working on a fatigue program that will be integrated into Femap. And that has been that's been a lot of fun. I get to learn about fatigue. and not being facetious, there's a lot to learn. And I want to close, I want to mention we have a training opportunity coming here in beautiful Portland on April 2nd to the 6th. And I want to mention that I've been sort of traditionally doing foundation, advanced, and customization. Well, I'm going to get rid of that differentiation between foundation and advanced. And the class is just going to be a 4-day class because the first 2 days we go so fast and we cover so much of the basic mechanics of FEA. we go in and we cover Gaussian integration, isoperimetric elements. It's really a condensed graduate course, and unless you have a graduate degree in mechanics, you're not going to get exposed to this stuff, and you're not going to see how everything fits together from a finite element perspective on plate, elements, solids, and beams. And plus, we cover so many tips and tricks the first 2 days that are not that knowledgeable, that if you're not there for the first 2, and then you come in, quote, for the advanced, it's a bit like drinking from a fire hose. We really go fast. And if you guys have heard these things, we use AVI's movie files, the way we teach it. And we do a bit of lecture, and then we come back in, and if you go into the advanced workshop, free body diagrams, everything is done. We do a bit of theory, background, and then you follow the AVI and try to replicate it. And these are takeaways. You guys leave with this course material. So if you come back and you wonder what's going on, you can always look at the AVIs and you'll get the course notes. And plus, we get a chance to know you, you get a chance to know us, and it makes the tech support phone calls go a little bit better. Well, anything else?
I think that covers it.
Okay, well, thanks for attending, and let us know if you have anything you'd like to see, and have a wonderful morning. Bye-bye.